So we're going to be looking at how to solve two-step equation word problems. And this is going to be really similar to solving the same way you set up one-step equation word problems. You're always going to start by looking for keywords to identify operations. Now, in a two-step equation word problems, what you should expect to see is two types of operations. And so there may be multiple keywords and that will identify the different operations. Again, there was a chart in an earlier stop that you received, and so you can look back at this if you're having trouble identifying the keywords. These are some, it's not a complete list, and they don't always mean the category they're in, but it's a pretty good place to start, at least if you're stuck. All right, so one I would just point out to you that a lot of times people forget is that of means multiply. And then again, I just want to remind you that less than and fewer than switch the order of however it's written. So if I have 14 less than something, I'm not going to do 14 minus, I'm going to do minus 14. Okay, so let's look at these examples. Company charges $2 for each balloon in an arrangement and a $3 delivery fee. You have $9 to spend. How many balloons can you purchase? All right, so I'm not seeing a lot of keywords here. Each is a keyword. So let's just understand basically what's happening. So you're buying balloons, and what are you paying for? You're paying for the balloons plus the delivery fee. All right, so that would indicate you would have to add something. It's $2 for each balloon, so it's like per balloon, and per means multiply. So I can use that. In this case, you might see each under division, but that's not what it means in this case. So, I'm going to use it as a multiplication word right now. So that's an example of a time where it is a keyword, but it may be in the wrong category. So $2 per balloon would be 2 times the number of balloons, which is what I don't know. I don't know how many balloons, so I'm going to let that be my variable, 2 times b. And then I'm going to add the delivery charge, which is 3, and then that's going to equal the total, which is 9. All right, once my equation is set up, I just solve it using the steps we've been using. Cut it in half. Let's get rid of addition first. We're going to do the opposite, which is minus 3. Okay, that leaves me 2b equal to 6. I need to isolate this variable, so I need to do the opposite of multiplying by 2. So I'm going to divide by 2, and then b is equal to 3. Then get back and check that answer. If I plugged 3 in for b, 2 times 3, that would be 6, plus 3 would be 9. So this is correct. And then what is it? 3 what? Well, it's 3 balloons were purchased if she spent $9. So I just want to interpret it at the end, 3 balloons. All right, number 2, Michaela has a collection of 20 rare coins. It means they're not easy to find if they're rare. This is 6 more than 1/2 as many coins as Axel has. How many rare coins does Axel have? Okay, so I don't know what Axel has. That's going to be my variable there. Here I'm seeing more than and 1/2. Both of those look like keywords to me. And then I know that Michaela has 20. So I'm going to use Axel to find Michaela is what this looks like. All right, so 6 more than. More than is one of those words that it's kind of like less than. It reverses the order. So instead of saying 6 plus something, I'm going to say something plus 6. It's not as important in addition because addition's commutative, but I want to just be in the habit of doing it correctly, so I'm going to do plus 6. 6, what am I adding 6 to? 1/2 as many as Axel. And I know that I don't know what Axel is, so I'm going to let that be my variable. So 1/2 of A, and 1/2 just means division. Okay, what are you dividing by? You're dividing it in 2 if you're making half of it, if you're taking it 1/2 of it. So A divided by 2, and then what is that equal to? This, which is who? Michaela. So Michaela has 20. Now you could write this with a fraction as well. I could have done 1/2 A plus 6 equals 20, and that would work also. I'm just choosing this time to use 1/2 as a division problem, but you could leave it as a fraction and do it that way if you prefer. All right, so I'm cutting my equation in half. I want to get rid of addition by doing the opposite, which is subtracting. So that leaves me with A over 2. 20 minus 6 is 14. And again, I'm still going to need to isolate the A, so do the opposite, which is multiplying. All right, so on this side I have A. On this side, 14 times 2 is 28. I'm going to check my work. 28 divided by 2 is 14. 14 plus 6 is 20. So this looks good, but what is it? 28 coins. All right, so Axel has 28 coins. Right? Number 3, Tanya had her birthday party at the movies. It cost $27 for pizza and $8.50 per friend for the movie tickets. Determine the number of friends Tanya had at her party if she spent $78. Okay, so per friend, per is often a key word. Let's see, determine the one. Okay, so she spent $78, so we want to know how she got to the $78. Well, she spent more than just money on her ticket. She also spent it for pizza. That also implies that we'd have to add something together, even though there's not a keyword being used for addition in this case. All right, $8.50 per friend means multiplied by the number of friends, which is what I don't know, so that's going to be my variable there. Now, I'm going to go ahead and write this equation based on what I see in the word problem. And then I'm going to talk about how this sometimes could be tricky. But in this case, I'm just gonna solve the problem like it's written. Okay, so she spent $27 for the pizza, so that's part of what she spent. And she spent, so plus, she spent $8.50 per friend. So $8.50 times however many friends she has. All right, and then determine, let's see. Okay, and then that's a total of $78. All right, so to solve this, I'm going to cut it in half. I need to get rid of the plus 27. All right, so not this part. I'm going to wait and do the multiplication part last. I'm going to subtract 27, Then this gives me $8.50 F, and then 28, let's see, 51. Now I can divide to get rid of the 850. Right, and so top in, bottom out. I don't actually need the zero, so I'm going to leave it off when I'm dividing. It's good for money, but I don't need it right here. I need to move this decimal over one place, so I need to add a decimal and a 0 in order to be able to move it over. So now I'm dividing 85 into 510, and I'm just going to guess 85 times, let's say 6. So 30, carry your 3, 48 plus 3 is 51. Yep, that would be 6. All right, so what I get as a solution to this is F is equal to 6, right? So 850, if I check it, 850 times 6 is 0, 30, 51, yep. And then if I add 27 to that, do I get 78? Well, yes I do. All right, so I know 6 is the correct answer, and it's the number of, what am I solving for? The number of friends. Now, that is the correct answer based on what they've told us. And sometimes these questions are trick questions, all right? So what they didn't tell us is if Tanya had to pay for herself or not, okay? So if this 850 also includes her, then she actually didn't have 6 friends. She actually had 5 friends plus herself. But it never says anything about Tanya having to pay for her own admission. So I'm just going to assume it's her birthday, she gets in free. And so the number of friends she was able to take is 6. But basically, maybe a better way to ask this question is how many tickets did she buy? So she definitely could have bought 6 tickets. Maybe that was for herself and 5 friends, or maybe it was for just 6 people total. Okay? So hopefully I haven't confused you with that. Number 4, Lacey is 4 years younger than Madison. The sum of their ages is 20. Let M represent Madison's age. Which of the following equations can be used to find Madison's age? All right, so I'm looking for keywords. 4 years younger than, that's a keyword. The sum, that's a keyword there. They want me to use M to be Madison's age. That's what I'm looking for, Madison's age. All right, it tells me Lacey. So just to kind of keep it straight, I'm going to say Lacey's 4 years younger than Madison. So younger than means less than. Okay, and remember, less than reverses the order. So this is not 4 minus Madison. This is Madison minus 4. Okay, sum means you're adding. What are you adding? You're adding Madison's age plus Lacey's age. So Madison's age plus Lacey's age, which is M minus 4, is equal to 20. So I get something like this. All right, so in this kind of problem, I like to write my own equation first and then see if it matches any of these. Okay, so let's look. And sometimes they may adjust this in order to get one of these, but we have to have a place to start. So this is a good place to start. All right, so in this equation, they have m minus 4 equals 20. I have m minus 4 equals 20, but I also have plus m. So they didn't add the Madison, so I know that one's wrong. M plus m plus 4 equals 20. That's very similar, but I have m minus 4, they have m plus 4, and I know younger than means minus, so this is not correct. C says 2m equals 20. So this is one of those cases where they might have adjusted. So I can see that there are two m's. M plus m would be 2m. But nowhere in here did they have the minus 4. They just have equals 20. So this can't be it either. So I'm hoping it's the last one. So in the last one, they have m minus 4 plus m equals 20. So they have the same thing I have, only they reversed these two ages. And I know that addition's commutative, so that order is not going to make these different. Okay, it's going to be the same because addition's commutative. So these are the same. So D would be the correct answer. All right, and then 5, you're going to be choosing the word problem that matches the equation. 2x plus 17 equals 23. And these are sometimes the trickiest. So when I look at a question like this, I kind of try to write my equation for each of the problems and then look at what the equation I'm trying to match it to is. But if I just try to read it and see if that's it, sometimes that doesn't always work for me. I start getting confused, so I'm just going to concentrate on one thing at a time. So it says Mark spent 23 days working on his research paper. This is 17 less than twice as many days as Brian spent. How many days did Brian spend? All right, so this, I don't know what Brian spent. I know less than and twice are both key words, so I'm going to go back and use these to write the equation. 17 less than, this is reversed, right? So it's not 17 minus, it's minus 17. Twice means times 2, and it's twice as many as Brian, which is what I don't know. So 2 times B minus 17 is what? This is referring back to what Mark had done, so 23 days. All right, so is this the same as this? Well, it's similar, except that I have minus 17 and this is plus 17. Less than is definitely subtraction, so I know I didn't make a mistake, so it's not A. John spent $17 on a concert ticket and then bought 2 t-shirts for $23 each. That's a keyword sometimes. How much did he spend at the concert? Okay, so I'm looking for a total that he spent at a concert. They don't use the word total, but total is really an addition type of problem. I know he spent $17 and he bought 2 t-shirts, so that would be plus the 2 t-shirts. Okay, so he bought 2 of them, and I know they cost $23, so I would have to multiply those times 23 to get how much he spent at the concert. So to get what he spent at the concert. So that would be equal to his total. All right, so is this the same as this? Well, it has the plus 17, that part's right. But it's not 2 times the variable, I have 2 times 23. They have equals 23. Okay, so this is not the same thing. So this cannot be B. Number C, Wyatt spent $23 at the arcade. He purchased 2 drinks and spent $17 on games. What was the cost of each drink? Right? Okay, so I'm not seeing really any of keywords here. I know he spent a total of $23, so that tells me I'm probably adding something together, even though I didn't use the word total. He purchased, what did he purchase to get to that total? Well, 2 drinks. And that's what I don't know because they're asking me how much a drink costs. So I'm going to say 2 times however much the drinks cost because he bought 2 of them. And, okay, so he also spent, so plus 17 is equal to what he spent in total, which is 23. So is this the same as this? Well, it's almost exactly the same. The only difference is they use X and I use D. Does it matter what letter it is? No, they're both variables. So it looks to me like these are going to be the same thing, but I'm going to go ahead and read this last one just to double check. All right, so half the number of male students increased by 17 is the number of female students. If there are 23 female students, how many male students are there? So my keywords I see here are half and increased. Let's see, how many male students are there? So I'm looking for the number of male students, so that's going to be my variable there. All right, so let's make an equation. Half, to me, is divided by 2, or you could do a fraction, 1/2. So half of the male students, so M, if I let M be the male students, divided by 2 increase, that's an addition word, all right? So plus what? 17, increased by 17, is the number of female students. Do I know the number of female students? Yes, there are 23. So equals 23. So is this the same as this? Well, in every way it's the same except for they multiply by 2 and I divide by 2. I know half means divided by 2, or at least 1/2 times m, which is not the same as times 2. So I know it cannot be D, and C is my answer. All right, so again, we're solving two-step equation word problems. So again, just identify those keywords and then solve the equation like you normally would. All right, see you soon.